working on. And therefore, as part of that, I'll be with you for the first 30 minutes of the meeting. Dae-Ho, who is my deputy, would be stepping in and also be the acting chair in my absence. Now, those of you who are not familiar with the INSOP was its International Network on Soil Pollution, which was launched in April 2022. And one of the reasons for this particular network is particularly in recognition of the United Nations meeting, I think in 2017, when they recognized that soil pollution is a major challenge globally. It's not about pollution of the urban environment, but also the agricultural environment as well, where we are confronted with diffuse pollution, but also recognizing that there are many of us who are not fully conversant with pollution. There's also not many of us who are trained to assess, manage risk and remediate contaminated sites. And therefore, the launch of INSOP was, on the one hand, for us to reach out to people globally, not just developed countries, but developing nations as well, to see whether there's a need for us to train people and build human capacity, and see whether we can come up with databases of that brings together some of the new technologies that we have from assessment, monitoring, and remediation of potentially contaminated sites. INSOP has a number of working groups, and today we are focusing on the remediation working group, and this working group has two chairs, co-chairs, Scott Warner, and Scott is from San Francisco, and he brings to us nearly 35 years of his expertise as a practitioner, as a consultant, absolutely outstanding. And some of the things that Scott has delivered from risk assessment and remediation perspective can't be matched, and hence the reason why we're delighted to have him with us. But with him also, we have Professor Fang Wang, who is an outstanding researcher publishing really good science on risk assessment, monitoring and remediation, but also taking the findings of her work out into the field. And I would like you to join me in welcoming both of them as well. And of course, Dae-Ho, who is my deputy chair, and he brings to us both contamination science and also as a practitioner, because he has been out in the field assessing and remediating contaminated sites. And not forgetting Sarjas, who is absolutely outstanding coordinator and never sits for one moment. He's always working there and delivering. So with that, I welcome you all to this meeting, and I also invite Sarjas, Scott Warner, to take us through his presentation. Over to you, Sarjas and Scott.
Thank you. Thank you, Ravi, for this wonderful opening. Indeed, we appreciate your kind words. Before we're going to jump to Scott's presentation, I would like to give a floor to Fang Van to remind us about the scope of this working group, remediation working group, and what it's all about. As you remember, last year in June, we defined our objectives and activities that we can do for each working group, and today is the time for remediation working group. We would like to have your help to help us realize those activities. So Fang going to guide us in a quick presentation to remind us all what was defined last year for this working group, and then over to Scott for remediation checklist presentation. Fang, over to you.
And so apologies, Fang, I should have mentioned you as the opening speaker. Thanks so much, Sarjas. Yeah.
Hello, good morning, good afternoon, good evening. So thank you all to join this working group meeting. I would like to introduce briefly about our working group. So our working group is mainly focused on the sustainable management of the soil remediation. Wait a second. So for our group, the objective is first we need to integrate the sustainable management and remediation practice and technologies for polluted soil. These are words widely used with special emphasis on nature-based solution because we are in the FAO domain, so we need to think about the nature-based solution for the sustainable management and remediation for the contaminated soil. The second is we need to strengthen the technical and technological capacity of sustainable soil management through coordinating among existing networks. So for us, we are a network. We also need to coordinate with other networks which are existing, and also in the future, if there's more networks comes, and we will also work with them. So for the priority, we have the priority. The first is we need to advocate for the development of national capacities and strengthen technology transfer for remediation and sustainable management of polluted soil. So that is our priority. So for efforts on the priority for the outcome, the first one is for our INSOP remediation database is widely localized. So we need to build up the database. We will have the discussion later on. The second is for the sustainable practice are disseminated among countries for remediating polluted soil and maximizing environmental, social, and economic benefits. So the aim is we build the database, and later on we could help the country for the remediation of the contaminated soil. So the key programs, the indicators for the long-term one, we need the international database of sustainable soil pollution remediation practice. This is available for the global use. We need to build up the long-term the database with a very long time. But for the short one and to the medium term, we need at least 60% of countries are represented through case studies in the global database. So later on, there will be also discussed about the case study. So our key activities we have for the first one is we need to agree on the definition of what is sustainable remediation and develop the priority to assess remediation technology. So this meeting will discuss about the sustainable remediation and management. The second is develop the remediation action plan checklist. So we have the checklist, and Scott will present soon. And launch a survey among INSOP members and global soil partner program partnership program focal point to identify successful case studies at the barriers in using sustainable remediation technologies. And INSOP members contribute to the development of a global database for the sustainable remediation of polluted soils to assess remediation technologies. So these are the current key activities. So we'll welcome all the members to join us. So thank you all. So now wait a second.
Yeah, thank you, Frank.
Back to Sergis, please.
Yes, thank you, Frank, for this presentation, reminding us what it's all about, why we're here, and what activities we need to do together. Now, as you can see from one of the activities is development remediation action checklist. INSOP steering committee has already done the foundation work in developing this action checklist. Now we have a big pleasure to present you in a nutshell what it's all about. And after that, we're going to open discussion to hear your thoughts and opinions, because before we're going to finalize, we need to hear your feedback and approval. So that's where you can step in and help us to finalize the checklist that was developed by the INSOP steering committee, primarily by Frank Bank and Scott Warner. Scott, we're eager to see you and hear your presentation about checklist. I know we have lots of participants, almost 90 participants here, waiting for this checklist to see. Please go ahead.
Well, let's hope we don't disappoint anybody with this. And thank you very much, Sergis, and thank you, Fang and Ravi and and Day and everybody else for being here today. It's a little after 5 in the morning here on the West Coast of the United States, and it's a pleasure to see so many folks from around the world. One thing I want to mention right away is that what we're going to present here is really a summary of what you will see in the checklist itself. Before the end of the month, you will be receiving an email from Sergis on your opportunity to participate in reviewing and commenting on this document. And what it is really a concise, almost extended fact sheet type document to assist the users in going through the steps by which to implement a successful remediation program. So let me share my screen here. That should, I believe, come up successfully, and you should be able to see it here.
That's right, we can see it, yeah.
Great, I'm going to presentation mode, and I hope that's works fine. All right.
No, that's not good because we see the presenter mode. You have to display settings and, yeah, display settings. Press on display settings at the top. Yeah, you see the arrow. You are right.
Let's see if I can see here. There we go.
Perfect.
Okay, now we got it. Apologies for already see the morning. Too early in the morning for me. All right, here we go. All right, we're set. So let's go through this presentation briefly over the next 20 minutes or so. And again, thank you for being here this morning. So the remediation checklist. Well, one thing I want to start with is that many of you online this morning, you're going to see what we're going to present here, and you're going to think to yourself, well, I've done that before. I've already seen that, right? But remember, the opportunity that we have as practitioners, as those who have been working for quite a few years, if not decades in this field, have this opportunity to share what we know with others who need to implement these programs around the world. We are the lucky ones, right? We've been able to become trained, we understand. Our job is to transmit this information to others. So that's what this checklist really is about, so that we actually can make more progress in cleaning and remediating those areas of impact. So we're going to start here with just some basics, right? What is soil remediation? Well, it's a complex process to restore affected soil to its original or productive state. We know it's a challenging exercise to be able to do this. So what we've tried to do is put together a system of checks, a system of processes, those that we're mostly familiar with, to allow the user to go ahead and reduce the occurrence of pollutants, improving physically, chemically, and biologically damaged soil to acceptable levels. But as you all know, and we all relate to this, is that it's a complex process. It's not something that you can go out today and expect for a completely remediated site tomorrow, right? We've worked on projects that are small, are large. They've taken years, sometimes decades, to implement appropriate remediation. But to do that, it is a skill, and it does take training, and it takes extensive planning, execution, use of science, and in particular, teams that are competent, are trained, and are highly qualified. And perhaps one of the most important objectives of this working group is to provide that recipe so that training can occur down the line. Communication and follow-up, and communication and communication and communication. You'll see that on the notes that I have at the bottom here. It's probably one of the most important things that we do, because remember, we're working with communities, social engagement areas that have not had this experience and what to expect. Our job is to be able to communicate that information to them appropriately. The process has a number of different parts to it, right? But starting with the objectives and the project drivers is probably most important right there. But you'll see in the slide that we've put together here a number of those different aspects that the checklist is intended to help promote. Important is that stakeholder satisfaction. That means that they have to understand what we are trying to attempt to do, understanding the risk within a given area, because we also know that remediation to zero, to before development, to remove every single molecule that may be impacting the site is often not doable. In fact, it might be even fairly impossible. But that doesn't mean that we can't reduce the risks efficiently enough to promote the return of that area, that affected land, back to productive and risk-free use. So that's incredibly important. But all these aspects go into the dynamics of a remediation project, and that's what the checklist is intended to help us with. I also want to make sure that we are consistent with the United Nations definitions of different processes and actions, including this whole concept of sustainable soils management. And that's this whole aspect of sustainability, the intention to have a sustainably remediated project. Professor Pishto will be talking about that a little bit later on, and a special welcome to him from me as well. I see he's from Ball State in Indiana. I actually did my graduate work at Indiana University in Bloomington, so you have a couple of Hoosiers here on the line with you as well. But remember the principles of sustainable soil management as intended through the UN Global Compact, right? We're protecting that soil from further harm. We're trying to restore impacted soil. We want to maintain the soil-based ecosystems, and that's really a tenet of sustainability. Enhance productivity of that soil area, that land, develop the knowledge systems and promote innovation in doing so. And again, you see that same word to communicate the importance of the land, of the soil, of its production for food, for health, for the ecosystem. Now, how about this aspect about sustainability? Within the checklist itself, while we don't call out sustainability and sustainable remediation directly, the envelope of sustainability is throughout the processes that we're intending to use, right? And we're looking at the long-term sustainable benefit of remediation. So within the process itself, we may end up with processes that don't seem that sustainable, right? Maybe they do use energy. Maybe they do produce water that has to be then treated itself. But at the end of the day, if we create a sustainable end result, then we've succeeded. Remember those three tenets and principles of sustainability, right? The social aspects, the economic, and the environmental. And if we can keep those in mind, and throughout the checklist, that is, again, that's the overriding envelope of what we're trying to attempt, then we will succeed. We're not defining sustainable remediation directly, although Professor Pishto will be talking about processes and projects around the world that take this in. The definitions are still wide-ranging around the world. There are various guidances, and I've provided one here, one of the ISO standards that was developed back in 2017. But remember that sustainability itself, by keeping those three tenets of social, environmental, and economic, will still get us to that final result. All right, so let's get into how we've set up this checklist. As I mentioned at the start of this, by the end of the month, you'll be receiving a link from Surges, from FAO, on your ability to contribute to review and comment of this document. It's a fairly short document. It's only going to be about 10 pages or so. What we tried to do in doing that are not the specific technical elements, the recipe of how to, but more of the overriding process that should be followed, right? And so we've divided this into 10 different steps, if you will. Each of those steps on the left here, from identifying the problem areas all the way to compliance and reporting, are organized within the document, and specific aspects under each of those are described. What I've done here for this presentation is to further divide it for convenience, if you will, into 5 topic areas: site characterization, risk assessment, the remediation action plan and implementation, the site restoration and post-remediation evaluation, and then compliance and reporting. And again, remember at the start, I said that this is going to seem pretty familiar to maybe a wide majority of everybody here on the call this morning, because we're familiar with this. Again, remember, our goal here is to provide a document and a how-to primarily for those who have not had experience within this, and we're able to help them get through this. So let's go through each of these 10 or 5 subdivided categories this morning. Well, site characterization certainly is our number one start. And site characterization is not just a one-time step, right? It is a, how should I say, a living type of process and document. Because we know that once we get to a site, and we start understanding, we look at the history, we start collecting data, we often find ourselves either needing more data, providing an evaluation that leads us to a different aspect and a different window, a different point. And so we continue to go through this. So we're developing, at the end of the day, a conceptual site model. And many of you are familiar with that, and there are plenty of documents that indicate how to describe that. That pretty much go through these different aspects of understanding the site, from source identification to identifying the fate, transport, and attenuation of those contaminants, to understanding data gaps and trying to fill them, and then developing our conceptual site model and going back to it again and filling in the gaps until we are comfortable enough to move on to the next step. So preliminary investigations to detailed investigations are all part of this particular step. I would like to refer everybody again to the United Nations and the Global Soil Laboratory Network as an opportunity to also use a global organization to allow us to understand different aspects around the world with regards to analytical capabilities, soil analysis and approach, and support. So once we get through the site characterization process, we can develop a mature, hopefully, conceptual site model. We still may need to fill that in, but remember the CSM is our directorate, our pathway to the next step, which is risk assessment. Within that risk assessment area, we're really using this as identifying the goals for which remediation may occur. Now, again, even though we would love to clean a site to pristine conditions, to zero, to before use, we often know that that's not a possibility, right? So we have to identify the risk drivers and the goals within that risk assessment of which our remediation will occur. So we are going through this process, and there's a model here on the right-hand side of the screen, which many of you may be familiar with, which identifies the hazards, exposures, the toxicity of the different elements that we're trying to deal with, the characterization, how to understand and describe that risk, and of course, a risk management process. Because at the end of the day, remediation really is about risk management. But this process of the site characterization results moving into the risk assessment program, and then from that, we identify the objectives and measures by which to develop our remediation plan. Fairly straightforward, but of course, it's a complex set of calculations, assessments, data collection aspects, and interpretations that need. So again, trained and qualified individuals, and that is called out within our checklist document. From that risk assessment process, we'll move into the remediation plan development and implementation. Developing a successful plan, however, takes quite a few individuals and folks with different types of training and understanding, both from the science aspect and also, as I've circled here at the top, from the social and community engagement aspect. And maybe that one of the failures that we've had as a practice over the last 40 or so years that we've been doing this is not communicating effectively the remedial action plan to the community and to those that are going to be most impacted by what we do. We want to emphasize this incredibly because from a sustainability perspective, from a success perspective, it's this communication aspect of the remediation plan development that is key. Now, within this, of course, there are a number of different technologies that we're to identify for that are appropriate for the site. Within the document that you'll have a chance to review, we're not going to have a list of technologies for you. Our goal is to identify areas of information that you can collect that data for the specific technology. I and Fang and others on this phone have been working with technologies for the last 30 plus years. We ourselves have, we know where we can go to get that information, but the general public and those who are trying to implement this in areas that don't have the experience may not. So our goal is to identify and push them in a direction that they can find that information. One aspect of the checklist that I think we want to also emphasize is in this middle part here. In implementation, the aspects of constructability, is a technology even possible for a given site, has to be emphasized, right? Because not all technologies will work for every different site. It's about that site characterization, conditions, the environmental aspects, the social aspects that are important. And we also note the immediacy or the timing, because we're trying to make a difference between emergency response and long-time sustainable protection. So those aspects also are to be called out, and we want to emphasize that timing is really important as well for how we approach from an economic and an environmental perspective. And of course, the follow-up, the monitoring and sampling. Again, this is where the global network is going to be important to understand, analytics are changing pretty regularly, pretty much every day, from looking at the perfluoroalkyl compounds, PFAS, to metals, to organic constituents. Those analytical technologies are improving. They're becoming more mobile. They're becoming more cost-effective. And so those different analytic recipes are part of what we have to continue to communicate outwards. Eventually, we'll get to the point where, don't forget, remediation itself does have an impact on a given land, on a given site, right? We may not still be able to farm, to have agricultural practices, to have other land use while we're under a remediation program, because there is an aspect of moving affected soil, of introducing chemical or biological techniques to treat that soil, so that for a time, that soil will not be productive the way we need it to be. But once we are done to our satisfaction, monitoring is appropriate, we've met the regulatory environment that we need to go into essentially bringing that now cleaned land back into production. So there's a whole aspect of site restoration and revegetation that's important. We wanted to call that out. This is not necessarily, I'd say this particular area is not one that most practitioners are necessarily familiar with. If you're like me, your job has mostly been to go in and make sure that the soil is now clean from the chemical contaminants that are a problem, but then it has to go to that next step, right? To make sure that it's now going to be usable once again. So we may need to make sure that that aspect is included. We've included that in this checklist as well. The idea that specific measures of restoration need to be communicated. The last thing we need to do is clean a certain area of land and then walk away from it. The public, the community are not going to appreciate that. They're not going to like that. We need to make sure that the land is returned back so that the local community can, again, put that back into production. And then finally, the post-remedial evaluation. This is where everything comes together, where essentially this is the checklist on the checklist that we have all done our job, and we need to promote this within this whole training exercise, where we're not only reviewing the action that has been implemented, but we can communicate the monitoring and verification results, get the feedback we need from the regulatory agencies, from the governments, from the social aspects, social community, and so we can document complete remedial success. All right. And the last point, of course, is reporting that we've complied with all laws, regulations, other aspects within the land itself, legal and economic, environmental, and we document that compliance and report it so that those later on can understand what has been done, and a bill of health is provided, and the agencies are accepting, and we can now move on, and that land is back into proper production. Okay, so let me get back to what we just did. This again, what we've tried to put into here is essentially 40 years of how we've approached these projects, how we've approached these sites. Again, the intent is a training exercise, not necessarily for everybody on the phone here or on the call here, but for those who are not familiar with restoration processes, right? That's to be understanding. So when you see this 10-page document, remember that this is that recipe that allows others to make sure that they have identified the different steps necessary to succeed. So on or about February the 1st, you will receive an email from Surgis or FAO. I'm not sure exactly who it will come from, but you'll get that to your inbox. And you're going to see essentially a request to provide comments to the document. It's going to look somewhat like this, where it'll essentially be a table where you can identify the comments by section name, by line number, by page number, by figure number or table number. Provide your comments, and then resubmit that back to the organization. We'll be able to collect all those results. We'll probably provide you some period of time to do that. We'll compile those results and work diligently to take what your comments are and implement them so that we have a final appropriate document that we can send out and make available to the general public. All right. That's where we are. Thank you very much to Fang, to Ravi, to Day, and to Surgis and all the others who have contributed to the working group over the past several months, over the last year. We appreciate that very much. And with that, Surgis, I think we can return it back to you.
Excellent. Thank you very much, Scott, for this concise, informative presentation. It was very interesting to hear. I hope that participants here on the phone learned a lot about the checklist, its content, and what is the scope of it. Now, as you said, communication is the key. So let's communicate now. We have an open session to address any comments or questions that you may have. So ladies and gentlemen, if you have any questions, please feel free to raise your hand regarding what you just heard. I'm going to give the floor to you if you have that specific question. Otherwise, you can feel free to put your question or concern in the chat box, and we will address it now. Now, Scott, if I understand, so yes, basically the members will receive email from me, from my email address on about February 1st, I guess. So we have still 2 weeks time to be sure that we within the INSOP steering committee are happy with the document. And then we're going to display it to the reviewers for everyone who is here on the phone, on the call, and to other INSOP members who were not able to join us today, but still in the registration list. And Scott, just before well, actually, I'm opening the questions and answers session now. Scott, we're not limiting ourselves to specific practice that we will receive, right? We will review all of them, and based on that, we will see how to progress, right?
Yeah, absolutely. Comments are acceptable from everybody. Actually, we want the more the better. The other thing I should probably mention is that the document that you're going to see, again, it's going to be a fairly concise, short. It's not going to be 100-page or more. How to document. That was not our intent. It's to make it fairly concise, but it's also not to be used necessarily alone, right? The idea, and Fang had mentioned this earlier, of collecting case studies, having the experience out there of what has worked and actually what hasn't worked, right? And combine that with this checklist is really the concept here, right? Because if you just look at the checklist alone, you're going to go, what am I going to do with this, right? It's really to focus the process and then rely on other experiences that have shown success. We realize we all know this, right? Every site is unique. There's no, you can't go down the street and find anything that's the same. And even though one site has arsenic and another site has arsenic, those two sites are completely different, right? So we have to be able to take those case studies in, apply the process, and work towards a successful project at the end of the day.
That's right. Thanks a lot, Scott. Yes, in fact, if we're calling it as a checklist or fact sheet, we have our FAO limits as well. So the fact sheet / checklist should not be more than 15 pages if we're publishing under the FAO rules. So that's why it has to be very concise. And indeed, checklist has to be very small, right? But it's very concise and informative. That's the key. Okay, I see we have a first hand raised. I see it's Sarah Haynes joining us here. Good morning, good afternoon, Sarah. Please feel free to unmute yourself and introduce yourself and where you're joining us from today and your question.
Good afternoon. You'll have to excuse me. I've got out of bed for this because I'm not very well. so I might be squeaky. I live in very rural Brittany, France. I have worked for 30 years in the UK contaminated land remediation field and still do remotely now. I'm fascinated by this, but my two questions. One is, I don't know if actually I'm a valid member of this group because you're very much talking about agricultural remediation and sustainable reuse for plant growth and such like, whereas I've predominantly, not always, worked on cleaning up old industrial sites so they can be used as public open space or developed as residential, that sort of thing. So first question is, am I actually a valid member of this group or not? Should I just go away and go back to bed?
No, you are absolutely, Sarah. You are a valid member of this group. My experience is not that different from yours. I primarily worked in the industrial world, but also in agricultural sites, water resources sites.
Okay.
It's all connected, and so the ecosystem is connected one way or the other. So the checklist should be usable for whatever type of site we're on.
Brilliant. So in that case, my knowledge about things like I'm a specialist in predominantly in landfill gas, old landfills, gas risk assessments, that sort of thing. Would that be of any use to this group? And I also have colleagues who are specialists in sustainable urban drainage, but that could also be very useful in non-urban areas in terms of remediation and, excuse me, storage of water. And am I able to involve other members of my company, my colleagues in this as well? Or is this a very enclosed group? I don't quite know. I've been ill for quite some time, so I'm only just re-engaging with this. Apologies. Am I able to share this video with my colleagues and then invite maybe them to, if I consider one of them is more relevant, appropriate, invite them to join in my stead?
Yes, again, excuse me, to all of the above.
Final question, and this is something we're starting to look into in quite some depth, is with remediation strategies during the options appraisal. One of the things we really do look at in depth is carbon footprint of the actual remediation works. Is that something that's too premature and too complex to engage in for the larger world? Or is it something that you would welcome observations and comments on?
Yeah, I can provide one comment, and I'm sure others may have. Fang, you may have some comments on this one as well, and John also with regards to the carbon footprinting. We've had this discussion with regards to kind of under that sustainability world and greenhouse gases and carbon footprinting. I think one of the answer is yes. It is an important aspect of assessing the project, right, and what we're implementing. But we've also talked about intention versus getting myopic or getting too closed into something that will prevent a remedial, the risk management project from going forward. And that's why I kind of mentioned this earlier, that we may have one process within a remediation program. Maybe it is overly carbon intensive, but for a short bit. But the goal is to get an appropriate risk management solution in place so that the long term does have that appropriate, sustainability aspect that we want. So
once again, it's going to be very site specific and very needs driven. Okay, thank you very much. In that case, I shall unraise my hand. If I can work out how do I unraise my hand?
Yeah.
Oh, do a hand, found it. Thank
perfect.
you.
Thank you, Sarah, very much. Fang, do you have any comments to any of Sarah's questions as well?
Thanks for the very nice suggestions. That's a good question. So Actually, for the remediation, I think nowadays we also need to concern about the carbon emission and the sequestration. I think when we select the techniques, this is also a very important issue we need to take into account. So we should also mention in our checklist. Thank you.
And just may I add to Sarah's comment, yes, priority for FAO is agricultural soil and agricultural pollution, because then we're food and agricultural organization, but we're not limiting ourselves just to agricultural soils, because pollution does not stop there. In the past, it was like this, but now we're seeing lots of members and countries asking for support beyond agricultural soil, and that's where we would like to extend and expand our opportunities. Urban soils, forest, lands, and protected areas, they're also part of our mission. So in short, we're not limiting ourselves just to agricultural soil, but that needs to be first, and then other land uses. Yeah. And you're feel free to feel free to invite other colleagues who will be interested, because all networks within the UN and FAO specifically, they're open, transparent, and everyone who's interested to learn and exchange their experience with us are welcome. And it's free of charge, of course, which is why we're organizing this and exchanging with the world and trying to exchange our possibilities from developed countries to developing ones, and eliminate the soil threats.
Merci beaucoup.
Okay.
I'll leave you to it. Thank you very much.
We have a chat message here. So people asking, is the presentation from Scott available offline? Well, it will be available once we close this meeting. We'll start compiling all the recordings and presentations from this meeting, and we'll upload everything shortly on our webpage. So if you missed any of those meetings, you can go to our webpage, INSOP FAO, and all the meetings, all the recordings are there, freely available. Question from Gaius Marturi from St. Lucia. The presentation is very good and summarizes a potentially comprehensive checklist which will guide technicians who are not familiar with soil remediation, especially SIDS, small island developing states and countries with limited human and technical resources. In fact, I totally agree with you, Guy, about this. We're trying to launch a project in SIDS. We're already working in the Trinidad and Tobago, actually building conceptual site model for soil pollution caused by heavy metals. But we're going to expand that to other SIDS countries in the Pacific and in the Caribbean, training farmer communities on soil pollution, and obviously disseminating our knowledge on soil pollution to technicians and practitioners around the world. Thank you for your comment. No other questions in the chat. Scott, Frank, any other comments from your side?
No,
okay.
Really just thanks everybody for your attention, and we look forward to your comments later this month.
That's right. In 2 weeks' time, you expect to hear from me about this checklist. It will be in a PDF format, so there's no need to edit or put on your track changes mode, but it will be in a PDF version. And if you have any questions or comments, significant ones, you will need to fill this out in the Excel template that I will enclose in my email. Okay, we're first time actually on time, which is good. So without further ado, I would like to close this activity. We're going to continue on this with the checklist once it's ready. And now we're going to jump to activity number 2. And for that one, I'm going to give the floor to moderate activity number 2 session to Frank. Frank, I see from the agenda we have the guest speaker now to introduce. Well, I give the floor, this opportunity to you.
Oh, thank you. So now it's our good honor to invite Professor John Pickle to give us a presentation. Professor John is from Ball State University. So please, the floor is yours.
Professor John, we can't hear. Oh, yeah, now you're unmuted.
Thanks very much. And I'm attempting to load my screen here. Bear with me for just a second.
No problem.
Okay. Can you see the screen?
Yeah.
Terrific. All right. So good morning, good afternoon, good evening, everyone. You've got the title of my presentation before you. We'll be discussing examples of sustainable site remediation practices from around the globe. My background is in soil chemistry. I've been training in this for about 4 decades, and this knowledge has been applied towards environmental site assessment, management of hazardous materials, site remediation, and other forms of waste management. Although I've been working in academia all this time, I've done quite a bit of environmental consulting, and I worked extensively with regulators, primarily at the local level.
Excuse me, could you present in the comment mode your slides?
I'm sorry, one more time?
So it's not yet in the present mode.
Ooh.
You need to click the slides on the right corner.
I'm sorry about that. Let me share.
There's a button actually at the bottom of your PowerPoint. You have to click and transfer it to the presentation mode because now it's currently in the.
I'm sorry.
Yeah, that button. Yeah.
Back up just a bit. Okay. I should know this by now. I've done this often enough. My apologies. So, colleagues, this is what we have to live with. A number of references have stated that there may be more than 5 million contaminated sites worldwide in need of remediation. And how did this come about over 100 or more years? I would say the top 4 bullets are the most notorious contributors to contaminated sites. Chemical releases from actively operating facilities, from active landfills, from former hazardous waste disposal sites, from leaking USTs, and some of you may have other items to add as well. In the European Union, it's estimated that about 2.5 million sites are contaminated worldwide. In the European Union, United States, approximately 1 million. If you're not familiar with the term Superfund, these are the most contaminated sites in the country, and more are regularly being added to the list. They pose an especially acute hazard to human health.
Excuse
Professor.
me, it is still not in the presentation mode. Could you try again?
I'm going to escape.
So you need to click
Screen sharing has stopped. Share screen.
yeah, share screen is fine. Share screen.
Okay, I'm looking for my presentation though, and I cannot find it.
Take your time. Oh, no worry.
INSOP. PowerPoint. Please let me know if you can see this.
Yeah, I can see your screen.
Can you see that I changed screens? Daggone it.
Double-click the presentation, please.
John, if you want, I can share my screen, and you're just going to give me instructions on when to jump to another slide. If that's okay.
Please do, yes.
I think that'll be easier.
Yes.
Yeah. Just stop sharing your screen. I'm going to share mine.
Everyone, I apologize.
No, don't worry. Okay. Although I have your presentation in PDF, but I think that's all right.
That's fine.
Okay. Can you see it?
Yes. Next, please. Next. So again, these are the primary sources of contamination worldwide. Next. It's estimated about 2.5 million contaminated sites occur in the European Union. I would estimate about 1 million contaminated sites in the US. Superfund sites are by far the most notorious and the most hazardous. Next. It's estimated that about 1/5 of agricultural soils in the People's Republic of China are contaminated. primarily with heavy metals like cadmium and semi-metals like arsenic. Next, please. And these are many of the technologies that we deal with globally. Unfortunately, some sources will list excavation and haul as a remediation technology. Personally, I've got a problem with that, but I'll do my best to be consistent with various sources. Pump and treat is also popular. On the right-hand side, land farming, phytoremediation, constructed wetlands. Some of these technologies are already essentially green technologies, and we'll look in more detail in a moment. Next, please. And this is where it all began, I'd say about 50 or 60 years ago. Oftentimes, due to political pressures, there might be a call to clean up a site, and that was carried out by dig and haul. In more recent times, 1990 to 2000, decision-making was based on technological feasibility. Can we pump out these liquids or vapors effectively? In current times, we're looking at green and sustainable remediation. And there's some confusion about the terminology here, but I'll clarify shortly. Essentially, we're looking now at sustainability benchmarks to clean up a site. Can we create public amenities following remediation? Can we be more efficient in use of energy? What will the final site use be? Next, Sergey. As mentioned a moment ago, some of the most common technologies are far from sustainable. Excavation and removal, pump and treat, oftentimes rank high in many nations worldwide. Next. And Scott Warner had a much more elaborate, a much more detailed flow chart showing the risk-based approach to site remediation. This is essentially an abbreviated version. A site may be discovered, investigation takes place, we carry out a risk assessment. Does the site pose a threat to public health and the environment? If yes, remedial methods are considered and the design is carried out. Next. It is agreed in many circles that such technologies are considered highly invasive, highly consumptive of resources, whether it be energy, soil, water. Many are expensive, with little consideration of side effects like energy uses and generation of secondary wastes. Next. We've had a definition of sustainability presented by Scott Warner. I'll just bring us down to the bottom. ASCAE definition, sustainable remediation is the set of environmental, economic, and social conditions, the so-called triple bottom line, where society has the capacity to improve its quality of life indefinitely without compromising future resources. Next. Next, please. So we've added a couple of steps now, in addition to the site discovery and investigation and risk assessment. In the consideration of remedial alternatives, we look at possible sustainability assessment tools, for example, life cycle analysis, to see if we can create a more holistic picture of remediation. Next. And again, I want to clarify between green and sustainable remediation. There's some publications that will use terms interchangeably. There are others who have specific definitions. Let's focus on this. Green remediation, according to US EPA and I believe SURF, this focuses on the environmental impact of the remediation process itself. In other words, can we use solar panels to extract groundwater? Can we use water recycling? Can we use biodiesel in our field equipment? Next. In contrast, sustainable remediation considers not only the remediation action, but also its economic and social implications. Can we benefit the community by way of this remediation action? Can jobs be created? Can public green spaces be created? Can we create habitat for wildlife? So that is the sustainable aspect. Next, and this is essentially the triple bottom line, which was mentioned in an earlier definition. Next, please. Again, United States, European Union have published a number of groundbreaking works, pun intended here, with regard to sustainable remediation. An excellent publication in 2008. Number of best management practices are suggested here. Next. American Society for Testing and Materials. This is a detailed, outstanding compendium of best management practices recommended for sustainable and green remediation. If you have not seen this, I do recommend you download this from the internet. Quite comprehensive. Next. And many of you are probably much more familiar with SURF than I am. What I have read, this also looks to be very up-to-date, very forward-thinking in terms of sustainable remediation technologies and management practices. Next. This is where we stand right now, according to some resources. Sustainable remediation carried out in the field has been addressed in North America to a limited extent, in Northern and Western Europe, in parts of the Japan, People's Republic of China, New Zealand. Next. Okay. Given that lengthy intro, I'm going to jump into actual examples of sustainable remediation in the US and worldwide. Some rather challenging sites here. Right off the bat is the Aberdeen Proving Grounds, which was constructed in 1918, obviously towards the end of World War I. This was a weapons testing ground. Chemical warfare agents and explosives were tested here. There was an open burning field in which a number of chemicals were simply dumped into the soil. And have a look at some of these concentrations, upwards of 200,000 parts per million of VOCs in groundwater. A number of technologies were considered for treating these burn pits. For example, soil washing and vapor extraction and pump and treat of groundwater. All of these were excluded from consideration for a couple of practical reasons. One being perched water tables, but also highly relevant, the fact that there are many unexploded bombs in the subsurface. So we really don't want to be mashing up that soil all too much. And you can have a look at some of the concentrations underneath these burn pits. Next. So phyto remediation was employed here. Hybrid poplars were placed into the soil, several hundred of these in some of the affected zones, in order to divert groundwater plumes, but also to transpire TCE and its breakdown products. A great deal of work had been done on capturing vapors volatilized, transpired from the leaves, and TCE has been transpired, and also compounds such as trichloroacetic acid, which is a breakdown product of TCE. So volatilization and decomposition has been occurring here. Next. This is an area where I've been intimately involved for over a decade. This is in the the Mesot district of northwest Thailand, close to the Burmese border. Photo on the far left shows the Padang zinc mine, which had been a very successful, very profitable mine, but management, to put it politely, of the soils was not optimum. And there was a great deal of runoff of zinc from the site, and also cadmium, which is often geochemically associated with the zinc. And those metals have run off into rice paddies, whose rice is used for local consumption, but also exported internationally. I don't know how familiar you are with toxic levels or excessive levels of cadmium in soil, but anything over 2 milligrams per kilogram is considered evidence of anthropogenic contamination. And here we've got almost 32 milligrams per kilogram. Next slide, please. Some of the work we've been involved in is experimenting with different rice varieties and other wetland species for extraction of cadmium and zinc. Some have been successful. Also, we're looking at stabilizing that cadmium in the soil using certain rice varieties, along with application of certain organic and inorganic amendments, animal manures, and leonardite. Right now, we're looking at the selection of metal-excluding rice varieties. This area will continue to stay in residential and agricultural use. The work goes on. Next. There's a case in Tricati, Italy, an oil well blowout. resulted in contamination of surface soils, TPH concentrations of close to 4,000 milligrams per kilogram. Remedial action was in the form of phytoremediation. During winter, fescue, colza, vetch, ryegrass were grown. During summer, corn, fescue, alfalfa, clover, and nearby there was some land farming that was taking place as well. This is about a 5-hectare site. Next slide, please. This work has been successful. Within a fairly short time, TPH concentrations were reduced to about 1/4 of original levels. Phytoremediation was found to be just as effective as land farming, and the vegetation held soil against erosion, and less resources, less laborious than land farming. Next, please. And colleagues, I can give you pages and pages of this, just successful field remediation activities using phytoremediation. Here I'm showing a few examples from Western Europe for heavy metal phytoextraction. Next. One of the drawbacks to phyto is that it is a slow process. Some other sites in Eastern Europe and in Northern Europe looking at phytoextraction of metals and rhizosphere decomposition of hydrocarbons. Again, I emphasize this is a slow process, but very low in terms of resource use. Next. Bioremediation, as with phytoremediation, these technologies have been in use for decades, but some are quite innovative. For example, at the Lieve Canal in Belgium, this is a canal that was constructed during medieval times, and upgradient for previous 100 years, a facility that produced asphalt and tar and asphaltic roofing products was active, and quite a bit of waste was dumped into the canal. And not too long ago, some of the canal was dredged, resulting in quite a bit of contamination in the canal. So the remediation strategy was the installation of mats, specially designed mats containing biochar and peat, with the idea that the biochar, which is very reactive, it's got a very reactive surface, can sorb quite a bit of the hydrocarbon, and also the peat has absorptive capability, plus it has a biological capacity as well. So a breakdown of many of these tarry compounds is taking place, as well as sorption. And I believe the preliminary 2 years of work is complete, but the scientists and engineers are so pleased with this work that they're continuing to use these mats. We've got some concentrations of contaminants on the lower left, some substantial concentrations. Next. Okay. Okay, next, please. Here's a beauty. Umatilla Army Depot in Hermiston, Oregon. That is in the northwest corner of the United States. This was a case in which wastewater enriched in TNT and RDX and other explosives was simply dumped into unlined lagoons. This was a mindset of out of sight, out of mind, essentially. And so this facility was left with enormous quantities of soil and groundwater contaminated with explosives. I don't know how familiar you might be with explosives chemistry, but in addition to being brisant, they're also highly toxic. So these soils were composted using windrows. These are elongated compost piles indoors, and this material was mixed with animal manures and alfalfa to provide nitrogen, also sawdust as a bulking agent. And please turn the page. Next slide, please. Have a look at these numbers on the lower right. The decomposition has been extremely rapid. My goodness, in the span of 3 weeks, the majority of TNT, RDX, and HMX, Her Majesty's explosive, had declined to almost nil. So highly successful. Obviously, machinery is still needed to turn these windrows, but the fact that composting was used, this was rapid with minimal resource use. Oftentimes, soils like this are sent to an incinerator, which has a high energy budget. Not the case with the composting. Next. Next, please. Okay, sustainable remediation can take the form of using renewable energy. Here's another ordnance facility, produced explosives during for World War II and Korean conflict. This is in Nebraska. This material entered an unconfined aquifer. Once again, we could employ petroleum-powered pumps, but the sustainable remediation process involved wind power to circulate groundwater or eventual removal of that groundwater for air stripping and UV treatment. I've got one eye on the clock here. I realize I've got just a couple minutes more. 10,000 liters per minute remove this contaminated water for treatment. Next. The wind system generates sufficient energy to operate the treatment system. And I don't know if I just mentioned this, but this water goes to a UV treatment system shown on the lower right. And surplus energy is generated, which is sold to the local grid. Next. Elizabeth Mine Superfund site. This is a former copper mine. The plan here was simply to level this land and cap it. It would require quite a bit of heavy machinery. In this sustainable remediation action, off-road vehicles like bulldozers were powered by electric diesel powertrains, and the engines were required to be Tier 4 compliant. Next slide, please. If you're not familiar with Tier 4, this is a requirement that particulate matter and NOx emissions be reduced by about 90%. So there was a substantial reduction in certain atmospheric pollutants, as well as a great deal of energy savings using this. And the site has been converted to a green space and a site for historic education. Next. St. Croix alumina plant, St. Croix Virgin Islands, petroleum contamination. This was a case where DNAPL had leaked from a refinery. Now this DNAPL is being pumped out using a hybrid system of solar panels and wind-generated energy to recover this NAPL and pump it directly back to the refinery to use it as a feedstock. Can't beat that. Next. Okay, next, please. Okay, another one, renewable energy resources. Here, solar power is used to pump out contaminated groundwater, which is eventually sent to a biologically activated carbon treatment system. Ultimately, the site has been cleaned to create a deep water port on the Delaware River off the coast of New Jersey. Large quantities of petroleum have been removed using a wide range of photovoltaic panels. Next. We go to next. Sustainable remediation can take the form of recycling and reusing materials on site. That includes concrete and steel and so forth. Next screen, please. Just one example I'll provide, a large illegal brownfield in Texas. This was contaminated with oily wastes, diesel fuel, quite a few metals, including lead and cadmium and chromium. One of the goals here, in addition to removing large debris, was to level this and make it an attractive park. So wood, which occurred in abundance at the site, was shredded and used for mulch, for trails. Metal was recycled, 32 tons of metal. Equipment was operated using biofuel generators and photovoltaic panels. Yes, and quite a bit of concrete occurred at the site, and it was crushed and used as part of the building infrastructure, and ultimately planted to native vegetation. Next. Okay, and incorporating a number of the previous concepts, I'll just mention green and natural infrastructure as a final product in sustainable remediation. Next. Okay, one site, Casper, Wyoming. This is a site that had been heavily contaminated with gasoline. This is a good flow chart here on the lower right. First, this gasoline is pumped to free water surface wetlands, then pumped underground to radial wetlands. Benefits of pumping it underground is that it can be quite chilly in Casper, Wyoming. I don't know what minus 35 Fahrenheit converts to in Celsius, but obviously this would freeze water if on the surface. And I believe this is powered by solar. Don't quote me on this. Next, please. Just a view of some of the wetlands next. My time is about up. treats up to about 2.5 million liters of contaminated groundwater per day, operates year-round despite the cold climate, and this is being converted into golf courses and a kayak run, as well as an office park and recreational facilities. So again, the sustainable aspect takes into account what happens during and after the remediation. So a number of innovative and creative uses for these sites. Next. We'll skip this one. I realize I'm about out of time. And as mentioned before, there are many initiatives out there. A few mouse clicks will get you to the data. Many of you may be more familiar with these than I am. I've got some sites listed for the UK and European Union. Next, for the United States, I've already quoted the EPA and ASTM. Japan, farther on down. Next. And I've got to close with this screen. As I said in my opening statement, I work with a number of regulators and with consulting firms and with industries. And sometimes I broach the question, what kind of green or sustainable remediation practices do you carry out for this particular site? And I will see a confused look, wrinkled eyebrows, and so forth. And many will say, look, we have to be on time and under budget. We've got to get this project complete so that we move on to the next one. So there's still quite a bit of education that we are responsible for sharing with professionals in the field, policymakers, regulators, industry individuals, and at the level of education. So the challenges before us, I do think this is an exciting time though. So everyone, I thank you for your attention. We'll stop there. I apologize for going over.
Thank you. Thank you for very nice, excellent presentation, and with even a lot of case study already. So we have some time for discussion. Does anybody has question?
Yeah, I just look at the chat. Professor Pitchell, thank you very much for this interesting presentation. I think we've learned a lot from your examples shown from the US, from Thailand, Belgium, and many other countries. That was very interesting. We have a fan question from the chat by Eric van Hulbush. Did you observe formation of explosive molecules degradation products? Question from Eric. John Pitchell, do you have any response to that question?
Okay, depending on the explosive, yes, there are many intermediate products. In a perfect world, microorganisms, especially in the rhizosphere, I found from my own research, can decompose many of these to the simplest forms, carbon dioxide, for example, or some simple organic acids. I neglected to mention in my presentation, I've done quite a bit of research with nitroglycerin decomposition in soils, and I've never had the results that were shown for the Umatilla Reservation, but short story long, yeah, TNT can decompose by many pathways, the carbon dioxide in water, the same for RDX, the same for HMX. However, in the case of explosives that are mixed with primers, for example, including mercury or lead, we will greatly slow down the biological remediation process there, obviously, because these metals are quite toxic. I can go on at some length if you like. Provide me with your email address. I've published a couple of papers dealing with decomposition products of explosives. I'll be happy to share with you some of my findings.
Thank you.
Excellent. Thank you very much. We also have a comment from Paul Nathaniel. Good afternoon, Paul. He's showing us the ISO 18504 from 2017 also deals with sustainable remediation practices, I guess, something to refer to in the future. I have a question from my side. John, you showed a very good table on phytoremediation plants that can be used to remediate and remove some heavy metals, but on only. I've seen also pesticides, and for pesticides use poplar, and that was used, I think, in Poland in the past. We're actually about to launch a project in Kazakhstan to remove and use sustainable remediation to remove opposite pesticides. So I wonder how much time it needs to remove those pesticides if you use some plants. Do we have such figures available?
Yeah, the field of phytoremediation, even though it's been active for decades, it is still wide open, to use a cliche. There are many plants that are yet to be investigated. Goodness, there are prairie plants. I don't know what the synonym is for Eastern Europe, but these are native vegetation to the central United States that have deep, very active root systems, and they may extend into the subsurface for 2 to 3 meters, which is quite remarkable. But again, biologically very active. They may have the capability to decompose certain pesticides, and some of these plants have been found to transpire pesticides through the stomata. One of the drawbacks with phytoremediation is that it is a slow process. It would be necessary to know what the chemistry is of these pesticides and attempt to find suitable plants. There's not always a perfect mix, and that's why research is still ongoing. The same goes for metal phytoextraction. Some species of plants, like Indian mustard, Brassica juncea, are very effective at removing lead from soil. It's not perfect, but it's incapable of removing certain other metals. And the same example could be used for a number of plants and heavy metals. I hope I answered your question.
You actually did. Yeah, thank you very much for letting me know. We have one more hand from Scott.
Thanks. Thanks, Urgis, and thanks, John, for that presentation. One aspect of remediation process and planning that we've started to talk about, and I know we had some presentations at some prior INSOP meetings as well, and it's part of my current research, is the effect of climate, particularly long-term climate change, on successful remedial applications, particularly in these large agricultural areas and other parts of the world where we see change. I know we had a presentation, Sturgis, I think it was from a site in South Africa last year on that. I don't know, John, if you've looked into those aspects as well, recognizing that some remedial aspects have to last for quite a long time, and changing conditions via rain, drought, etc., runoff can have an impact on what's applied. So curious at your thoughts and experience in that area.
Yeah, I suppose this falls under the umbrella of sustainable, resilient remediation. Can we locate a treatment scenario that is suitable in the case of rising sea levels and rising temperatures, maybe increased salinity of soils? I've been working with some faculty in India on identification and support of plants that can tolerate higher levels of salt and greater levels of drought. But that work is really in its beginning stages. There are a number of plant species that have potential for phytoremediation that are C3 plants versus C4 plants. Yeah, they hold promise for phyto, not so much extraction from what I've seen, but decomposition in the rhizosphere. I confess my knowledge is more on, temperate region plants and soils. But yeah, there are certain plants that hold promise.
Great, thank you.
So we have a question from Sarah. Speaking of parent plants with very deep roots, as native species, will these become invasive plants?
Speaking of prairie plants with very deep roots, as non-native species, I'm afraid I don't know. And you bring to mind an interesting point. I've been doing research on phytoextraction of lead from soils, and I found that giant ragweed, Ambrosia artissimifolia, is very effective at lead removal. That's very promising. It produces a lot of biomass, but it is an invasive species. I mean, who wants to see 7 hectares of an invasive plant to be used? So, these things need to be considered. As far as prairie plants, they are native to the central and north central United States. I would not recommend bringing them to another part of the world. I would much prefer that native plants be used just to avoid this issue of invasion. There has been some research with genetic engineering of plant species to put a hyperaccumulating gene into a local plant. Personally, I've got reservations about that. I say now let's keep that in the laboratory and don't dare put it in the field, but that's a personal opinion.
Oh, okay, thank you. So Sarah's response is that's what I was wondering, not the rainberry plants, but any plants you were using.
Okay. Yeah, again, the ragweed, outstanding lead accumulator, but I would not dare use it in a large scale system. I found that there are some agronomic plants and some varieties of corn, for example, and some varieties of alfalfa that are effective in phytoremediation. And so, once again, I must emphasize this is still a very open area. There's so much we don't know about effective plants, which ones are best. Even within alfalfa, for goodness, there are scores of varieties of alfalfa, Medicago sativa. Some are effective in hydrocarbon degradation and some are relatively worthless. That's just within one species.
Yeah, we agree with you. So thank you, Joe, once again for your very nice presentation. Thank you. And
Thank
now
you.
we move to the next session. So now we open the floor for an open discuss. We need to discuss about the approach to develop a global database on sustainable remediation. So anyone, if you have any question or comments or ideas, just raise your hand.
Yeah, thanks a lot, Frank. Indeed, for this discussion, it's quite important for us to build such a global database. And I think we have a very good foundation that we see from John Pitchell, right? John, you've shown your slides some countries who already have a database from the US, from EU, Japan, UK. I'm not sure if we have something in China, Frank, on the practices that are used in sustainable remediation or not, but it will be interesting to exchange these opportunities and ideas of who is using what in different countries, right? So we've seen a lot from the US today and Belgium one, for example, on phytoremediation, on phytostabilization, immobilization. So that basically needs to be the aim, right, Scott, Frank, to develop and agree on what will be in that database.
Yeah, absolutely. That's one of the goals here, right? We, as John mentioned, some of us have more experience in one kind of environmental climate than others. So we need to take the experiences from around the globe of what's worked. And the other thing I want to stress is what hasn't worked. I think that's often the information we have trouble accessing, but yet it can be absolutely important to defining and designing the right approach for a given area. So. We want those experiences as well that didn't quite go as planned or expectation, as well as the ones that do work.
And then also, since we're working here at FAO, we will ask this question also our focal points, which are usually the ministers of agriculture who represent the actual country that they're coming from, and let us know whether the government is actually willing to implement sustainable remediation and what are the actual barriers for them not to do that. Now, we've seen a very good examples from South Africa last year when researchers showed to us what phytoremediation technologies they use. But they have also challenges to do it everywhere in the country because of other constraints that they're facing.
Yeah. We also should be taking information and experiences from other parts of the environmental industry. So I know Sarah asked the question earlier about whether industrial background is still useful for agricultural background. When we think of mining reclamation, for example, right? Today, mines have to be, when they're closing a mine, you have to make by regulation in many countries, you have to make it last for hundreds of years, not thousands of years. And so there has to be a consideration on changing conditions. And taking that information and applying it back to the agricultural world might also be very useful for us. So I think part of our search for other examples is to reach beyond as well to these other practice areas that will be helpful. And that's certainly what we'll be doing over this coming year.
So I think okay, please.
Now, the proposal that we had last year is how to collect this information. The easiest one is to develop a survey and disseminate among all members and focal points, the ministers of agriculture, who can tell us and exchange that information, share that information with us, given the references and the links that we can verify and include in the database. For example, John Pitchell used in over the last 20 minutes, we've seen more than 20 examples all around the world that you just covered. I'm sure we can receive more than that at the end if we're going to disseminate the survey among members. Frank, what was your thoughts?
I think this survey is a very good idea. I think we can send the survey via the email or post on the website, and even for post on the social media. And then I think then within a while we could collect some cases. Especially John has showed us so many cases, so we invite John to join us first.
I didn't hear the last part of the question. Could you repeat?
So you have showed us a lot of very good cases.
Yes.
So we would like to invite you first to join us to help build up the database.
Yes, please keep me in mind. Thank you. I will point out that when I was preparing for this presentation, in some cases, it was relatively easy to find data and reports on sustainable remediation technology. The US EPA has published quite a bit. In some countries, it was quite difficult to locate published articles or government reports. In the case of Japan, I was in trouble because I can't read Japanese, but that's another story. But there's not one single body of data. And so I think this would be an exciting opportunity to do our homework and compile this information for different countries. It's going to be a slow process probably, or maybe I'm being too negative.
Thank you. So Danilo, sorry, please.
Okay, thank you. First of all, thank you all for your support and your presentation. I think this is a very interesting group. And yes, I do agree with the fact that I mean, there are a lot of case studies, very interesting case studies, and I think we can all work on that. I may raise a point with both the checklist and the case studies that we've seen, talking about the original land use of the site and our objectives, our goals. So in terms of the future land use of the site. So for instance, we've seen examples of former mines, for instance. So I think one thing that may be interesting to see is that we are remediating after investigating and all the different steps. We are remediating. So the fact that we need to focus also on the objectives of the remediation. So do we need the soil for like agricultural purposes? So the fact that we could link the effectiveness, for instance, of a remedial technology to the land use that we want to have of that site following remediation. I think this is a crucial point. So if we talk, for instance, if we talk about phytoremediation, which is very, very interesting, I can tell you that in Italy, unfortunately, it doesn't happen very often, unfortunately. But the fact that if we take, for instance, the case of a former, I don't know, mine, could we actually use that type of remedial actions to convert, let's say, the site and in order to be able to use it for agricultural use, considering FAO.
If you're posing that as a go ahead. I was going to say, if you're posing that as a question, Daniel, I think Scott had made a point in his presentation that essentially there's no cookbook set of technologies for cleaning up a site. I mean, each site is going to differ in terms of its contamination as well as soil physical properties, groundwater chemistry, and so forth. In answer to your question, it is certainly possible, and there are many documented examples of rather toxic sites being converted to green spaces or to agricultural use. I'm familiar with a number of metal and coal mines in the eastern United States that have been remediated, and one site was pH 2.5, very toxic and very barren, and now it's converted to agricultural pasture land for cattle. So, I mean, the answer is it's possible. It's not possible. In every case, again, it depends on the site and on situation. Very important question. Thank you.
Yeah, I think I mean, to conclude, it's an interesting point also when we all will be providing, or we will be discussing case studies, like maybe not a lot of numbers, but just to as you did in your presentation, let's say the initial situation with the contaminants and the final situation that was reached, just to have an idea of the even the future end use that we want or we could reach for that site, for that specific site. But yeah, I definitely agree on what you just said. Thank you.
Thank you.
Thank you. I see the question in the chat box. So is there any sustainable method for remediation of medical wear, like plastics? Does anybody know there's any case about the remediation of the plastic or other medical waste?
Okay. If I may, I'm looking at this and a subsequent question, how to treat plastic contaminated soils and remediation of medical wear, like plastics affected sites. Okay, part of my research group has now devoted itself to microplastics contamination and remediation. And boy, such an important question. I don't know of any sustainable remediation method for treatment of plastics contaminated soil. They are designed to be recalcitrant. They're designed to be water resistant and biologically resistant and so forth. So as far as a sustainable remediation technology, that is a tough nut to crack. And biological remediation and phytoremediation are essentially non-players in this. They are not effective for plastics. Again, I repeat, just plastics are designed to be resistant. So very difficult one to handle. So this is a whole new area of research only for the last 3 or 4 years for my research group.
Yeah, that probably goes into how we define then remediation again, right? Because it goes again into the risk management process. Is it isolation? Is it some sort of other aspect where you can keep that risk away, even if it's not completely removed? And I think that's where the creativity and science are going to have to continue to evolve together, so that we can find those solutions. Because you're right, especially nanoplastics, I mean, the smaller and smaller particles, tough enough to even analyze to see if we have those particulates there, but we're seeing more and more of them. So yeah, stay tuned, I think is
right.
Right.
Which is why the reason why INSOP decided not to dedicate a lot of attention to nanoplastic and microplastic these days, because we're literally starting from the scratch. Okay, we can talk about awareness raising and alternative solutions, but how to remediate and remove nanoplastic using phytoremediation sustainable techniques, that's still to researchers to go and not to FAO.
So Sarah's response from experience, net fuel mining, the removal of bulk rather than nanoplastic is physical process.
Okay, it's going to depend. It will depend on the size of the plastics. Yes, plastic particles can be floated from this landfill debris. So the heavy sediment can settle out, whereas the plastics will rise up. All that's needed is a large bath containing either sodium chloride or zinc chloride. That is of sufficient density to allow the plastics to float. But I think one of the earlier questions was, is it possible to treat plastic contaminated media sustainably? And I think right now the answer is no. But yeah, we can devote quite a bit of fossil fuel energy and run these pumps and systems. And remove plastics. I will point out also there are technologies like wet air oxidation, which are extremely effective for breaking down micro and nanoplastics, but they have a very high energy bill. So they're certainly not sustainable.
Okay. So actually the microplastic or nanoplastic in the agriculture field is still quite challenging. So we need to work together to find solution to make sure we could have a sustainable and green use of plastics, especially in the agriculture field. We use a lot of fuel, so that's a big challenge. We need also do some work on this field. I have another question. Does anybody know if the soil was contaminated by the pathogen or virus? So is any good technique or any case about the remediation or sustainable management of contaminated soil?
Did you say pathogenetic soil?
If the soil is contaminated with a pathogen or virus?
Okay. Well, I mean, if I may cut in again with a response, I don't want to dominate this discussion, but composting is available, which can crank up the temperature to a biopile to, this is degrees Fahrenheit, but 120, 130 degrees Fahrenheit, and that will kill bacterial pathogens, viruses, possibly, but there's some researchers in the People's Republic of China that have developed a high temperature composting or thermophilic, I don't remember the exact name, composting, whose temperatures are even higher, which can eliminate many more viruses. So I think the technology is already out there.
So for the manure or biosolids, this is feasible. But if the soil is already contaminated, the soil with big land, still very challenging, I think.
Oh yes,
Thank
okay.
you.
That if we're talking about the soil in place, that is quite a challenge. Yes, because these pathogens can migrate down into the soil profile, and they can remain in a spore state or in some resting state for decades, literally. Yeah, so if that's the case, if we're talking about agricultural soils of some size, that's a difficult challenge.
I have a question, specifically to you, Frank, and all the other Chinese colleagues who are here. John said that language barrier can be an issue for us to find and extract information, like something that was in Japan that they experienced. In China, it will be an issue for us to find information in English language, or everything's only in Chinese language available?
So for us, most cases are in Chinese because our official language is in Chinese. But when we write publications, and we could write in English and in Chinese. But for the document itself, in most cases in Chinese, like the guidelines and so on.
Suraj, I want to add a little bit of reflection on the global database on sustainable remediation. I think right now the largest database is in the US because the US EPA managed to collect a lot of case studies. However, I mean, based on what I see, most of those case studies are written in very simple format. So it provides quite limited information on the one hand. On the other hand, most of them focus on the use of renewable energy. For example, solar panels, wind power, and so on. So I think, it's kind of a narrow focus. Of course, there are some good studies about the use of best management practice. But I think, when we aim to create a global database, I think one good source is academic literature, because in the sustainable remediation field, right now there's a fast growing body of literature. If we do a search right now, I think that there's more than 1,000 papers which mentions sustainable remediation. Of course, I mean, a paper mentions sustainable remediation doesn't necessarily mean it's a good case study, but I mean, some of them can be turned into good case studies. I mean, usually when the scholars write a paper about a sustainable technology, about a life cycle assessment of a cycle remediation project, I mean, usually they have a lot of information. The key is, I mean, usually the scholars have some information about the case, but I mean, the site owner maybe willing to share the information with the scholar, but not necessarily with say INSOP to put it on the international platform. But I think, I mean, we can probably talk to the scholars first to see whether they are willing to convert those academic studies into a case study to be shared with the whole sector. That's one thing I think we could do. As for in China, I think this may be there may be similar experience in other places as well. In China, remediation is usually considered confidential. Like, I mean, the site owners do not want to release the information. The government doesn't want to release the information either. The reason is that they worry that there could be social unrest for the people who live around those contaminant sites. However, there's a caveat. I mean, there are some projects which was done well. Projects which say we use the nature-based solution, and it has very good pictures to show, good story to tell. The site owner and the government may be quite happy to share such stories. I mean, most recently in China, there are few such studies. I mean, one notable study was just occurred recently in northern China. I mean, initially the remediation was not very successful. I mean, there was a lot of complaints, but eventually they identified a nature-based solution and converted it into a urban green space. And it seems everybody was happy, and it was everywhere in the newspaper. So I think cases like that can be very good candidates for our collection. And I'm talking about all this because I'm trying to I mean, this is kind of brainstorm. I'm thinking, I mean, we have nearly 100 people attending this, but right now the discussion about collecting sustainable remediation cases are not very. I mean, John talked about a lot of cases, but we haven't really collected a lot of cases from the other participants. So I'm kind of throwing out some ideas to see whether the other participants can recall some candidates in their countries or their regions.
So that's a good idea. If anyone would like to share the cases from your country?
Yeah, I think the thing is that it's not easy for people just to say from their mind, oh, this is the site that I'm familiar with, right? It will require a bit of homework for all of us to understand that, for example, in Ireland, where I'm based, we have those case studies. I will need to look at it, but although I'm pretty sure we have something in the country, but I cannot mention this. So, which is why I believe that doing a survey and openness to members and non-members actually will help us a lot to collect that information, unless you, Day and Frank and Scott think that we need to have another approach for it.
I understand the caution that folks will have too, right, in providing information that are specific, because as Dave was mentioning, there's some governments that don't want that information for a number of reasons. So we have to be aware of that. But I think even empirical evidence and kind of observational information can be helpful. I was noticing some of the comments in the chat, for example, about unintended consequences, right? Other processes to try and remove a contaminant that lead to secondary problems. We may not even need to know the exact location of a given site, But if we know the issues that come up, I think that even helps us with this whole survey, Sturgis, right? So maybe in our request for information, we can let folks know that they should be comfortable with whatever level of information they can provide us, even if it's not 100% complete, because it can still be helpful as we're trying to gather the different experiences that that can benefit, you know, the overall goal here.
Noted.
We have still a few minutes to discuss about maybe to discuss how to do the survey. What key elements we should think about when we do the survey?
Yeah, we have an important comment here from Samina saying that designing remediation technique is difficult when we're dealing with heterogeneous medium to treat, like soil on the groundwater, because the remediation practices varies for that. Totally agree. Yeah.
Yeah, totally agree.
Yeah.
You know, one reason why the development of the picture, the conceptual model, and is so important, because you're right. All sites are unique that way and heterogeneous. But there's a lot of collective experience out there, and that's the goal of trying to collect this information and apply the science. But you're right. Single remediation. There's the other comment here. Single remediation strategies may not be singular, right? They evolve over time, and for a given site, different techniques may be appropriate. So that's part of the experience. That's part of the training that we're talking about, right? To provide these the methodology out there of what has worked, what doesn't work, and how to excuse me, how to visualize a site as you get into it and collect the data. That's important.
So there's another question is how to access and quantify the cost effectiveness of the remediation methodology across regions. So so that's
and
why
there's another comment just came from Ilona saying that help can be offered. That's from TAO Netherlands, I see. Please offer some case studies of sustainable remediation for the database, but will require permission from the client and collection of information. For example, colleagues were involved in the design of the reactive mat in Belgium, and we have designed peat cap for hazardous waste dump site in the Netherlands. Okay, so here we have a thought that the permission from the client and collection of information will be necessary.
So, and then another question what they ask here is to try to include as many countries as possible. So here I would like also invite everyone here, or even your colleagues and friends who are interested, to join our survey when we send out this week. Thank you.
This week is too ambitious, Frank. I don't think we will be ready for this week. I'm too busy. So let's give a bit of a time. Let's finish the checklist, and then we're gonna, once we open the review process for the checklist, we're gonna design the survey, right? But I think the foundation can be done already based on examples that we've seen and what we know, and that can be a very good accumulator factor to have more case studies. Yeah, I'm just thinking about the permissions that was mentioned by TAO Netherlands. Dave, do you think that will be an issue that we're going to face? as you mentioned, not many authorities or clients will be willing to displace this information.
I think if we can present some good case studies to show that it brings more benefit to the client and the practitioners than causing troubles, I think we will have more interest in this. Because what we are offering is an international platform. I mean, we are trying to transfer experience and knowledge to a very broad audience. I think, I mean, from a societal impact perspective, I mean, this is very valuable. But I think we need to convey this message to the clients, to the site owners.
I think the objective that we intend to do the database, the final goal is to benefit for all the country and all the people. That's why we are trying to spend so much time to work on the database. So the time is almost finished for the open discuss. Now I give the floor to Sergius. Sergius, please.
Yeah, thanks a lot, Frank. Well, that was very interesting. Just before we're going to go to the summary that will be delivered by Dae Ho, I just want to highlight that sustainable remediation will appear a lot in the conferences this year. And we already seen in the chat that Paola Greni already announced that RemTech Expo will take place in September this year. September 23rd. I'm going to post the link in a second. And also there's another conference organized by INSOP Chair, Professor Ravi Naidu, on Cleanup Conference that will take place also in September in Australia. So you can have a look at those conferences if you're interested in. Please feel free to register. And if you know any other conferences related to remediation or soil pollution that are upcoming in your country or elsewhere, please feel free to drop us an email, because we have our INSOP newsletter circulated once in 3 months' time. And that's where you can announce and advertise your conference, your publication, recent publication in soil pollution. And yeah, that's INSOP is a good opportunity to offer you this free announcement. So please feel free to reach to us because we would like to be as open as possible with any upcoming activities that are taking place. Okay, well, Dae, we're looking forward to your summary.
Thank you, Serge. We just had a short 2-hour meeting. This is the first working group meeting for the remediation working group. And I think we had some very fruitful discussion. Fan talked about the priority areas. I mean, Scott went through the comprehensive checklist of remediation processes. And John gave us a very good overview and a lot of case studies on sustainable remediation. All these talks are very informative. I think it laid the ground for us to reflect and to move forward. And with tonight's discussion, I do see that we on the one hand, there are a lot of things that we can do together. On the other hand, we do have challenges to meet the priority, the goals that we are setting here. I think we mentioned about like 60% of the countries to get some case studies. This will really require the help of a lot of our members, and we will. I'm sure that we will organize more meetings to figure out. A good template to collect information and a good presentation style to make sure that we can share knowledge and share information on the one hand. On the other hand, we don't release confidential information that either the working party or the site owners want to keep. And for the remediation working group, the biggest contribution will be sharing, will be knowledge transfer, will be sharing of knowledge. When we talk about this, I think different countries have very different practices. When it comes to sustainable remediation, there are there are very good consensus on like minimizing the environmental footprint, maximizing the social and economic benefits. But on the other hand, I mean, different countries have very different regulatory framework, have different requirements about their practices. So when we try to transfer this knowledge, we need to keep in mind, on the one hand, we want to provide the other parties useful technology, useful experience. But on the other hand, we do not put the regulatory boundaries. I mean, because for something that's not allowed in one country, may be allowed in another country, vice versa. So I think this is something that we need to work together to work out a good mechanism to share these case studies. And I also encourage our members to think more about what we can do. Just from the number of participants we have in today's meeting, I can see that there is a lot of interest in the activities in this working group. I think a lot of things that we could potentially do to utilize this international platform to promote sustainable management and remediation efforts in tackling global soil pollution. So with that said, I want to thank you all again for participating in tonight's discussion, and I look forward to more meetings in the coming year. With that, back to Sir Julius.
Thank you, Day. Well, I guarantee we're going to have lots of meetings this year. As I said, 2024 will be very enriched in soil pollution indeed. Okay, thank you very much, Day. So action for all of us, well, for INSOP Steering Committee, 1st of February, deadline for us internally agree on the checklist. And after that, I'm going to reach out to all members that are here and registered with the INSOP to get involved in the review process of the checklist if you're interested to be a peer reviewer. And secondly, once we've done that, mid-February, we're going to finalize a survey for collecting information on practices of sustainable remediation and sustainable management. And lastly, if you're still not registered as INSOP member, you can easily do so via INSOP FAO. That's the only way, registering your email address in the registration form. That's the only way for me to ensure that you're going to receive and be up to date about all the upcoming information, upcoming meetings that we're going to have. With that, thank you very much to John Pichtel for joining us as a guest. Thank you very much, John. We're looking forward to collaborate with you in this insightful and very challenging task. Scott Werner, thank you very much for your presentation. Day Ho, thank you for helping us navigate this meeting. And thank you very much to my moderator, Frank Wang, for helping to moderate this session. Thank you very much. Happy New Year to all of us. And let's keep in touch and work together. Thank you. Have a good rest of the day.
Thank you.
Bye-bye.
Thank you.
Thank you.
Have a nice
Bye.
day. Bye-bye.
Bye-bye.